Welcome to this course. My name is Kazam Ali and I am the instructor of this course. The course name is Computer Vision and Deep Learning. Actually, we solve different computer vision problems with the help of deep learning algorithms in this course. So first we see what is computer vision and then we see what is deep learning, what are deep learning algorithms. So let's start from computer vision definition. Computer vision, often abbreviated as CV. CV is defined as a field of study that seeks to develop techniques to help computers see and understand the contents of digital images, such as photographs and videos. The problem of computer vision appears simple because it is easily solved by people or human. Even very young children solve the computer vision problems easily. Nevertheless, it largely remains an unsolved problem based both on the limited understanding of biological vision and because of the complexity of vision perception in a dynamic and nearly infinitely varying physical world. So, why computers need to see images? Because we are awash in images in these days. Smartphones have cameras, and taking a photo or video and sharing it has never been easier, resulting in the incredible growth of modern social networks like Instagram. YouTube might be the second largest search engine, and hundreds of hours of videos are uploaded every minute, and billions of videos are watched every day. The internet is comprised of text and images. It is, a rel- it is relatively straightforward to index and search text, but in order to index and search images, some algorithms need to know what the images contain. For the longest time, the content of images and video has remained obscure, best described using the meta description provided by the person that uploaded them. To get the most out of image data, we need computers to see an image and understand the content. This is a trivial problem for a human, even young children. For example, a person can describe the content of a photograph they have seen once. A person can summarize a video that they have only seen once. A person can recognize a face that they have only seen once before. We require at least the same capabilities for computers in order to unlock our images and videos. Or, or we can also say the unlock contents of our images and videos. So, computer vision. Computer vision is a field of focused on the problem of helping computers to see at an abstract level or high level. The goal of computer vision problem is to use the observed image data to infer something about the world. Computer vision is the automated extraction of information from images. Information can mean anything from 3D models, camera position, object detection and recognition to grouping and searching image content. What is the difference between computer vision and image processing? So, computer vision is distinct or different from image processing. In image processing is the process of creating a new image from an existing image, typically simplifying or enhancing the content in some way. It is a type of digital signal processing and is not concerned with understanding the content of an image. A given computer vision system may require image processing to be applied to raw input. For example, pre-processing images. Example of image processing include normalize photometric properties of the image such as brightness or color, cropping the bounds of the image such as centering an object in a photograph, removing digital noise from an image such as digital artifacts from low light levels. What are the challenges of computer vision in these days? The goal of computer vision is to extract useful information from images. This has proved a surprisingly challenging task. It has occupied thousands of intelligent and creative minds over the last 4 decades. Despite this, we are still far from being able to build a general purpose seeing machine. Another reason why it is such a challenging problem is because of the complexity inherent in the visual world. A given object may be seen from any orientation, in any light conditions, with any type of occlusion from other objects, and so on. A true vision system must be able to see in any of an infinite number of scenes and still extract something meaningful. Computers work well for tightly constrained problems, not open, not open, not open, unbounded problems like visual perception. Tasks are users of computer vision in these days are listed as the different tasks which computer vision has completed in the real world are as under. First, optical character recognition, machine inspection, retail means automated checkouts in retail stores or a big markets or mall, shopping mall. 3D model building means photogrammetry, medical imaging, automotive safety, match move, merging CGI with live actors in movies, motion capture, surveillance, fingerprint recognition, and biometrics. Object classification. Object classification means what broad category or main category of object is present in the photograph. Object identification means which type of a given object is in this photograph. Object verification, it checks whether the object in the photograph is present or not. Object detection, what are the objects in the photographs or how many objects in the present in the photograph. Object landmark detection, what are the key points or important information for the object in the photograph, or determine the key points or important or necessary information for the object present in the photograph. Object segmentation, what pixel belong to the object in the image. Object recognition, what objects are in this photograph and where are they. It means in object recognition we also find the location of objects and we also find the class or category of the objects. Other, other common examples are related to information retrieval. For example, finding a new image like an existing image or images, like an existing image or images. No. What is the use of deep learning in computer vision? Okay, deep learning is another field, but but mostly used in computer vision. Not in, deep learning is not used in computer vision. Actually, deep learning is used in all fields. In all means many fields. Deep learning algorithms are used in many fields. Okay, but now we see the deep learning algorithms which are used in computer vision field. Okay, deep learning algorithms are used to do various tasks in computer vision, such as automatic feature extraction. What are automatic feature extraction? Uh, Automatic feature extraction we will study in the next lectures, because this is our introductory lecture. So we uh, so in this lecture we study a high level definition of the concept. High level only I present or describe the high level presentation of concepts. Okay. A major focus of study in the field of computer vision is on techniques to detect and extract features from digital images. Extracted features provide the context for inference about an image, and often the richer the features, the better the inference. The promise of deep learning is that complex and useful feature can be automatically learned directly from large datasets. More specifically, that a deep hierarchy of rich features can be learned and automatically extract, extracted from images provided by the multiple deep layers of neural network models. End-to-end models. The deep neural networks allows a single model to subsum two or more traditional models such as feature extraction and classification. It means deep learning algorithm at the same time extract the features and also classify the objects in the image. It is common to use a single model trained directly on raw pixel values for image classification, and then has been a trend toward replacing pipeline that use a deep neural network model with a single model trained end-to-end directly. A good example of this in object detection and face recognition, where initially superior performance was achieved using a deep convolutional neural network for feature extraction. Model reuse. Deep neural networks are typically trained on datasets that are much larger than traditional datasets. For example, millions or billions of images where deep neural networks are trained for these datasets. This allows the models to learn features and hierarchies of features that are general across photographs, which is itself a remarkable. Superior performance. An important promise of the neural networks in computer vision is better performance. It means deep learning algorithms give better performance than traditional computer vision algorithms. It is the dramatically better performance with deep neural networks that has been a catalyst for the growth and interest in the field of deep learning. Although the techniques have been around for decades, the spark was the outstanding performance by Alex Krinsky in 2012 for image classification challenge. This trend of improvement has continued year over year on a range of computer vision tasks. We can observe we can observe significant performance improvement since deep learning algorithms entered the entered the scene in 2012. Journal method. Perhaps the most important promise of deep learning is that top performing models are all developed from the same basic components. The impressive results have come from one type of network called the convolutional neural network, comprised of convolution and pooling layers. Convolutional neural network is a very important network and is a deep learning algorithm but mostly used in computer vision field and has achieved so and used for to do many tasks of computer visions to do many computer vision tasks and is a much popular algorithm in the field of the world of computer vision. So we study in the next lecture convolutional neural network in a great detail, and we also see its theory, concepts, and then we practically implement CNN on different data sets and see its performance and also see its performance of different data sets. Okay. CNN was specifically designed for image data and can be trained on pixel data directly. Deep learning model Deep learning models used in computer vision. Deep learning is a large field of study. Not all of it is relevant to computer vision. It means deep learning field is used in other field also. From a high level, there is one method from deep learning that deserves the most attention for application in computer vision. It's, it is convolutional neural network model or algorithm. And in short, it is also called CNN. So it is often called CNN. The reason that CNNs are the focus of attention for deep learning models is that they were specifically designed for image data. Additionally, both of the following network types may be useful for interpreting or developing inference models from the feature learned and extracted by CNNs. They are multi-layer perceptron recurrent neural networks. The MLP or fully connected type neural network layers are useful for developing models that make predictions given the learned feature extracted by CNNs. RNNs means recurrent neural network such as LSTM, long short-term memory, may be helpful when working with sequences of images over time such as with video. So this is the introductory lecture of computer vision and deep learning. So in the next lecture, we see we describe the different tasks or concepts of computer vision, and then we solve these tasks or problems of computer vision with the help of deep learning algorithms. So see you in the next lecture. Thanks for your time.